Hello everyone, welcome to another video. In this video, I will be talking about the root cause analysis of the P1 production incident that I recently handled. So this is my second video on this P1 production incident. I have already done one video where I have spoken about this incident in much more detail and how I handled the incident as a senior SRE, what troubleshooting steps I performed. So I recommend that you watch that video and then come to this one so that you are able to relate the things better. Anyways, I'm still going to explain the P1 production incident, what it was, what happened, so that you are still able to relate things before I speak about the root cause analysis of the issue. So recently we experienced a priority one production incident where a website component suddenly lost access to a few files that were stored in Amazon S3 bucket. At first glance, the issue appeared to be an IAM permissions problem. However, the actual root cause was far more subtle, which I'm going to discuss in this video. What exactly happened in this issue? Users began reporting that a banner displayed on the website was no longer visible to them. The banner relied on assets stored in an Amazon S3 bucket, and the application could no longer retrieve them. This was the issue. So, from the application's perspective, the error appeared similar to an S3 access or a permission problem. Okay, and since this problem impacted all the users, it was immediately classified as a priority one production incident. Now, if I talk about the root cause analysis of this issue, so during the root cause investigation, the application team discovered that this issue was linked to a shared internal library used by multiple applications. This library provides some common functionalities. It is related to several Java dependencies so that the application teams do not have to implement everything from scratch. They can just pull it and use it in their application. However, the latest version of the shared library introduced a major change. So this shared library, it upgraded its AWS SDK version from V1 to V2. The problem was that the main application, it was still built to work with only AWS SDK V1 version. So since we were using this shared library, it was using AWS SDK V2 after the recent release. And the application was still built around AWS SDK V1 version. So due to this issue, this created a compatibility issue. So what happened internally, that the main application code expected AWS SDK V1 APIs, but the shared library that this application was using, it introduced AWS SDK V2. So the S3 client behavior changed internally. So due to this, the application could no longer properly interact with the S3 bucket. As a result, the system behaved as if it had S3 access issues, even though the IAM permissions were actually correct. Okay, as I spoke about in the last video, that the platform team identified and they did not find any changes done to this IAM role, which was being used by the application to access the S3 bucket. So this was the root cause. Now, if I talk about why our QA testing did not catch the problem. Okay, so this is like a very natural question that appears in each of the post-incident analysis discussions. So, I mean, why did the QA did not detect the issue before production release? So, there are several factors that contributed to the gap. So, if I talk about a few, so all our QA tests passed successfully. So, the application went through standard release testing. Okay, if I talk about the testing, we do functional testing, we do regression testing, and we also have smoke testing configured for this application, and none of the tests actually failed. So it was a sign that our changes have been successfully accepted and there are no issues at all. The second thing is the application service was always healthy. As I mentioned, from a monitoring perspective, the application remained up and running no crashes occurred, no service level no service level alerts were triggered. So traditional health checks passed successfully. Okay. Then if I talk about the third point, so missing runtime integration tests. The QA test suite primarily focuses on application service health, not any external service behavior, in this case S3 bucket. So there was no integration test validation done to find out the runtime S3 interactions with the application. So just because of that, the S3 compatibility issue went undetected. Okay. Now, if I talk about how how the library upgrade was introduced. So one more important discovery during the investigation was related to the release process of the shared library itself. The shared library team had recently released a new version as part of a routine upgrade cycle. The upgrade including several dependency changes, including the move to AWS SDK v2 version. However, the application team was not aware of this change. Okay, so yes, I think it is like kind of a miss from the application team, because with each production release you get the change log as well, and whenever you are using any of the libraries from the shared library platform, you need to carefully review the change log and see whether all the changes are still compatible with your application before using any of it. So the compatibility with the existing application was not validated. This allowed the incompatible dependency to enter the production build. So now if I talk about what preventive measures were identified during the RCA discussions. So the root cause analysis identified several improvements that can significantly reduce the likelihood of similar incidents. We can add some functional monitoring for critical UI elements. The incident revealed that the system had no monitoring to verify if the banner was actually visible. So our future improvement includes we should have some synthetic monitoring for the key UI components. We should have some automated checks which are going to validate the banner availability. Then we should also have some end-to-end functional tests running periodically. Okay, so these tests should always pass. If this fail, if these tests fail at any given point of time, so we can be alerted that there's something wrong in the application. Then if I talk about some other things, that we are also going to introduce integration tests for S3 access. So as I mentioned, the test suite will now include runtime validation for critical dependencies such as S3 as well. Okay, because we have just learned that S3 access can still be impacted, so we should have some integration tests done just for that. So these tests are going to verify whether the file upload to S3 is working, the file retrieval from S3 is working, the permissions are validating or not, or we can also include SDK compatibility test as well. Okay, so these are the things that the application team is going to work with us, with the SRE team, to set these things up. Then also there was one more thing that the application team identified, that they can still strengthen their regression testing coverage. So the existing regression tests primarily validates application availability but not its behavior. So the future regression test will also include external dependency checks, storage interaction validation, and runtime API compatibility testing. So these are the things that the application team is going to work on. Apart from that, we can also enforce dependency compatibility reviews. Okay, so whenever the application is using any shared library, and if the shared library has a new version, okay, so the teams must review the change log. Okay, so the change log information is going to give us all the details whether the new version is still compatible with our application or not. So all the dependency upgrades, they must be validated thoroughly by the application team. SDK version compatibility must be confirmed. This step is critical for avoiding unexpected behavior in production. So these are some of the things that the application team is going to take care of. So I hope this video was useful to you. I spoke about the root cause analysis of a P1 production incident, and SRE role is always dynamic in nature. So you will always have something to improve on day-to-day basis. So this was one of the incidents where we can still make some improvements in our existing process so that we can avoid a high priority incident in future. Alright guys, that's all I wanted to cover in this video. I request you to please hit the like button, please share this video with others, and please do subscribe to my YouTube channel. Alright, that's all for this one, and I'm going to see you in the next one. Bye for now.